Hi children, how are you? In the last class, we discussed some problems related to series connection and parallel connection. In this class, we are discussing about heating effect of electric current. We know that a battery or a cell provides the electrical energy required for an electric circuit to work. Am I right? Okay. We already studied about resistors. What is resistors? Resistors is a device that provides resistance. Then what is resistance? Resistance is the property of a resistance is the property in which the flow of electrons gets blocked. Here, when I connect a resistor in this circuit and a bulb is here, this is the electric cell, a current will flow through this. But here, when it passes through this resistor, the current will get blocked. Not all current, some of the current. Some of the current is blocked here. Here the resistor blocks some of the current. How is it blocked? That is, here this electrical current means electrical current. It is an electrical energy also. We can say it is an electrical energy. This electrical energy is converted into heat energy. Then this energy is converted into heat energy, and that is some of the current here is converted into heat energy. This electrical energy is consumed in an electric circuit as heat. Okay, is excluded, is dissipated from this electrical circuit. That is, here the resistor is connected. The resistor blocks the electric current. Some of the current is converted into heat energy. That is, we know the electric current is an electrical energy, and this electrical energy here is converted into heat energy. That is, some of the electric current is converted to heat energy, and some of the current goes from here as heat. That is, this wire, we know the resistor is a wire, and this wire gets heated when current flows through it. That is, this electrical current is converted into heat energy. Okay, hope you clear that. I give only the concept of heating effect of electric current. What do you mean by electric power? Electric power is the rate at which electric energy is dissipated or consumed in an electric circuit. Okay, electric power is denoted by the letter P. Okay, here it is the work done by time. That is, power is equal to work done by time. This is the equation for power, that is work done by time. Okay, that is P is equal to W by T. This is an equation for power. And this work done, we know this work done is equivalent to the energy dissipated. This power is equal to energy by time. Energy by time. That is, P is equal to E by T also. Okay. This is another equation for power. What is power? Power is the rate at which electrical energy is consumed in an electric circuit. Okay. Then electric power, the equation for electric power can be written as P is equal to W by T. That is work done by time. Work done, it is the energy, electrical energy by time. Okay, P is equal to E by T. We know the equation for potential difference. We have studied it in the previous class. What is the equation for potential difference? Potential difference V is equal to work done by charge. Do you remember this equation? Potential difference V is equal to work done by charge. We all know the power P equal to W by T. We can find this work from this equation, that is W is equal to V into Q. Okay, then we can substitute this value into this equation, that is P is equal to VQ by T. What is Q by T? The rate of change of charge is called electric current. What is Q by T? Charge by time is equal to current. We studied in the first class, that is charge by time is the electric current. That is, we can substitute this as Q by T as I, electric current I. This is the another equation for power. That is, this is the relationship between electric power, potential difference and the current, that is P is equal to V into I. And it can be written in another form. According to Ohm's law, what is the equation for Ohm's law? That is V is equal to I into R. First, I substituting this value for V in this equation. That is, in the place of V, I am substituting I into R. Then, P is equal to V equal to IR. V equal to IR. I into R into I. Okay. We already said that I into I. What is I into I? It is I square. 2 into 2, 2 square. 4 into 4, 4 square. Similarly, I into I square. R is the resistance. Okay. This is the another equation for electric power. This is the relationship between electric power, current and the resistance, that is P is equal to I square R. Then next equation, there is remaining one equation, that is P is equal to V. We start from the Ohm's law. According to Ohm's law, what is I? Current. I is equal to V by R. Am I right? I is equal to V by R. Now I am substituting this value into this equation. Then we will get P is equal to V into I. I means V by R. That is V by R. Okay. Then V into V, it is V square by R. Here we get 3 equations for power, that is P is equal to V into I, P is equal to I square R and P is equal to V square by R. This is very important, and there is another equation also, P is equal to W by T, that is work done by time. We have to do some problems relating to these equations. Okay. Then what is the unit of power? The SI unit of power is, what is the SI unit of electric power? The SI unit of electric power is watt. SI unit of electric power is watt. Watt can be denoted by the letter capital W, capital letter W. Then how can we define 1 watt? We can use this equation to define 1 watt. We can use this equation, that is P is equal to I into V. Suppose I is equal to 1 ampere and V is equal to 1 volt. Then what will be the power? That is P is equal to 1 ampere into 1 volt. That is 1 into 1. That is 1. What is 1 watt? That is 1 watt. Here power is equal to 1 ampere. That is for 1 ampere current and for 1 volt potential difference, we will get the power as 1 watt. Then how can we define 1 watt? That is 1 watt is the power consumed by device that carries how much current? That carries 1 ampere of current when operated at a potential difference of which potential difference? 1 volt potential difference. Hope you clear that. How can we define 1 watt? 1 watt is the power. It is a power. 1 watt is the power consumed by a device that carries, and that device must carries 1 ampere current and operated at a potential difference of 1 volt. Okay. Hope you clear that. That is 1 watt is equal to 1 volt into 1 ampere. It is very important. You will ask to define 1 watt for your exam. I already said that the heating effect of electric current means in a circuit there will be a resistor and there will be an electric cell. This is a simple circuit and the current will flow through this circuit. Some of the electric current gets consumed by the resistor, that is, it is converted into heat energy. That is, we know the electric current is a form of energy, that is electric energy, and this electric energy is converted into heat energy. Or otherwise we can say that here the energy get dissipated in the resistor as heat. The amount of heat H is produced here is, here our motive is to calculate how much amount of heat gets produced in the time t when I current flow through this. That is, for the resistor of resistance R, how much amount of heat is produced in time t of an electric circuit carrying electric current I. Okay, there is an equation for this. That is, there comes the Joule's law of heating. The Joule's law of heating says how much heat will produce here. Joule's law of heating. Joule's law of heating gives how much energy get converted in the resistor as heat and how much the amount of heat is produced in time t. That is, here suppose the heat is H and here the amount of heat produced is H and the current is I and the potential difference is V and the resistance is R and time is t. Okay. Then according to Joule's law of heating states that here the heat produced in a resistor, heat produced in a resistor. I already said that some of the current is converted into heat here. Only some current will pass through it and the other current will converted into heat. That is, and that heat produced in this resistor is directly proportional to. Heat can be denoted by the letter H. That is, heat is directly proportional to the square of the current. That is, I is the current, that is square of the current. Okay. And the next one is the heat produced is directly proportional to the resistance. Okay, and the third one is the heat produced is directly proportional to the time, that is the time for which the current flows through the resistor. In the resistor, the current will flow through the resistor, and how much time it takes to cover it takes to flow, the current takes to flow through the resistor, that is the time here. That is, heat produced is directly proportional to the time. According to Joule's law of heating, heat produced in a resistor is directly proportional to the square of the current, resistance and the time. Okay, then by combining these three equations, we will get H proportional to I square R into T. That is, H is equal to, I already told you, when you convert this directly proportional into equal to sign, we have to multiply it with a constant. Let the constant here be K. K into I square RT. Here K is equal to 1. Okay, here the constant K is equal to 1, then H is equal to I square R into T. This is the equation for the heat produced in a resistor. The sum of the current here is converted into heat energy, and this heat produced can be calculated by using this equation, that is H is equal to I square into R into T. Here H is the heat produced, I is the electric current passes through this circuit, and R is the resistance of this resistor, and T is the time taken to flow the current through the resistor. Okay, hope you understand that this Joule's law of heating is very important. Okay, this equation can be rewritten as, then we know according to Ohm's law, V is equal to I into R. That is, I is equal to V by R. We can substitute this equation, this I in this equation, that is H is equal to I V by R all square R into T. It can be written as V square by R square into R into T. That is, R get cancelled. Then we can write as V square by R into T. That is, H is equal to V square by R into T. This is the another equation for heat. Then the next one is H is, we can substitute for resistance. First we substituted for current, then we can substitute for resistance. Then R is equal to V by I. Okay, that is H is equal to I square into R. In the place of R, we can write this value, that is V by I. Okay, into T. T is there. Then I and I get cancelled. That is, one I get cancelled. Okay, then we will get I V into T, or we can write it as H is equal to V I T. This is the another equation for Joule's law of heating. That is, according to Joule's law of heating, H is equal to I square into R into T. There is another equation also, H is equal to V square by R into T, and H is equal to VIT. These three equations are very important. There will be some problems. We have to do some problems relating to these three equations. Okay. I already told you that power is equal to work by time and power is equal to energy by time. Here energy is the electrical energy, or we can say that electrical energy is equal to power into time. Electrical energy is equal to power into time. Here unit of electrical energy is, Here unit of electrical energy is watt hour. Watt hour, or we can denote it as watt hour like this. Okay. Then what is 1 watt hour? How can we define 1 watt hour? That is when 1 watt into 1 hour is equal to 1 watt hour. That is here 1 watt power and 1 hour time. That is equal to 1 hour electrical energy. That is 1 watt hour is the electrical energy consumed when 1 watt of power is used for 1 hour. When 1 watt of power is used for 1 hour, we will get an electrical energy of 1 watt hour. Okay. What is the commercial unit of electrical energy? You can see in your home there is the electricity bill. In the electricity bill you can see how much kilowatt hour current energy is used. That is the commercial unit of electrical energy is kilowatt hour. That is the, we commonly say that unit. Okay, unit is equal to kilowatt hour. 1 kilowatt hour is equal to 1 unit. In some, it is very important, in some problems you have to convert watt hour into kilowatt hour. 1 kilowatt hour is to 3 kilo 10 raised to 3 watt hour. That is 1 kilowatt hour is equal to 10 raised to 3 watt hour. You have to convert, in some questions we have to convert watt hour into kilowatt hour, and this kilowatt hour is known as unit. Okay, hope you clear that. We can write 1 kilowatt hour. 1 kilowatt hour is equal to 1000 watt into 1 hour. That is 1000 watt into, we know 1 hour contains how many seconds? That is 60 into 60 seconds. Arthur. Okay, that is 1000 watt into 3600, that is 3600 seconds. It can be written as 3.6 into 10 raised to 6 watt second. We can write 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joule. Very important. Sometimes you have to convert kilowatt hour into joule. In this class, we discussed about heating effect of electric current and the electric power, the equations of electric power, that is P is equal to I square into R, P is equal to I into V, and P is equal to V square by R. Okay. And we also studied that Joule's law of heating. According to Joule's law of heating, the heat produced is directly proportional to the square of the current and the resistance of the resistor and the time for which the current flows through the resistor. Then we studied also some conversions, kilowatt hour into watt hour and kilowatt hour into joule, and this kilowatt hour is commonly we called unit. Okay, you can see it in the electricity bill. Okay, in the next class we will discuss about practical applications of heating effect of electric current, and we will do some problems related to these equations, that is the equations of electric power and the equations of Joule's law of heating. Okay, hope you understand all this. Then we will continue in the next class. Thank you.